Let's take a look at specific heat. All right, here is our equation for specific heat. You have Q. Now Q stands for energy, and the label is joules or a capital J. You can do a J like that too. C is the specific heat. We'll talk about that one in a moment. M is mass, and delta T is the change in temperature. Note, you must do final minus initial. That's very important because it tells us whether or not the object is heating up or cooling down. So make sure you do that. Specific heat has a unique label. It's joules per gram degree Celsius or joules per gram K. And it literally has a definition. It is how much energy does it take to raise 1 gram 1 degree Celsius. And it's got an unusual label because when you do algebra, this side of the equation must be equal to this side. But we already know we have grams and degrees Celsius. So what would the label need to be right here so that all we get is joules? Well, joules per gram degrees Celsius, because then those cross off. So that's why it's kind of odd looking. So let's look at how we can use this equation. A 500 gram cube of lead is heated from 25 to 75 degrees Celsius. How much energy was required to heat the lead? The specific heat is 0.129 grams per degree Celsius. So Q equals Cm delta T. Well, I have mass, I have temperature, and I have the specific heat. So Q equals 0.129 times 500, got to be in grams, and then it's going to be final minus initial, which is 50. And when you plug all that into the calculator, you get, where'd my answer go, you guys? You get 3,225 joules. That easy. You can also use this equation to find other things. Let me show you how you do that, okay? And I remember this, by the way. Q is the queen, and the queen watches country music television. Haha, I know. And if you struggle to remember labels, well, the Q is the queen. And doesn't the queen always wear jewels? Ha, ha, ha. That's how I remember it. Okay, so what do we have on this one? A 25 gram, all right, that's mass, is heated 200 degrees Celsius. Well, that's temperature. 2,330 joules. Oh, that's Q. What is the specific heat? We're looking for C. You're going to do this in a lab, by the way. So 2,330 equals C times 25 times the temperature change is 200. Well, either multiply and simplify or just divide everything by that. However you want to do it. It doesn't matter to me. And you get the specific heat is, I've got the answer right here, 0.466 joules per gram degrees Celsius. That easy. So remember, if you get a value of Q and it's negative, well, why? Well, that's because when you do final minus initial temperature, you get a negative value. Well, what does that mean? It means your object, your metal, is cooling down. And if you get a positive value, well, it's heating up. So it really is important that you get that correct because it's going to tell you whether or not your metal is heating up or cooling down. And that is how easy it is to use those equations.